Hi, and welcome to the NIRStar Refresher. Before we jump into it, please make sure that you have the correct hardware to be used with NIRStar. NIRStar is intended to be used with either our NIRScout series systems or our NIRSport 1 system. To install NIRStar, you can head over to our support page at support.nirx.de, log in, and then go to the software page. There, we will have access to the most up-to-date version of all of our software, including NIRStar. Once you select NIRStar, there will be different installation methods. First, you'll have to choose between a build or an installer version. The build version is meant if you had already installed another version of NIRStar in your computer. If you're not sure about it, or you're doing this for the first time, just go ahead and use the installer version. Next, we have two resolution options that have to be chosen depending on your current screen resolution. We recommend the low resolution version for laptops and the high resolution version for big monitors. Once you know what version you need, you can go ahead and click on the download link, keeping in mind that NIRStar is only Windows compatible at the moment. With NIRStar properly downloaded and installed, make sure that your NIRx system is connected to the computer and turned on before starting up the software. Now, let's go ahead and take a look at NIRStar. Once it opens, if you get a pop-up asking for a probe info file, don't worry, you can ignore that for now. And once it loads, it will take us to the landing page. If the system is properly connected, there will be a green online indicator over to the top right of the page. Right below it, we can also see information about the hardware, an experiment notes section where we can type notes before and during the experiment, a system status tab, and the number of sources, detectors, and the scan rate of the current configuration. Now, let's move on to the hardware configuration menu. The first tab there is the predefined montages tab, where we can select an available montage or create a new one. If you have recently installed NIRStar, it should have a few pre-made montages that you can explore. If you'd like to create a new montage, you can click on New, give it a name, and then select the necessary files. We recommend always using a topo layout file and a probe info file, which are the output of our montage creation software, NIRSite. You can download NIRSite for free on our software page. We have a similar video to this one that can get you started with the software, and we'll make sure to share that link with you either on the video description or on the live chat. Once you have a montage selected, you can go over to the Channel Setup tab, where we see the illumination pattern for the chosen montage. This pattern is what ultimately sets the sampling rate and can be changed if you need a higher one. Next, in the Topo Layout tab, we can see a topographic display of the montage. The layout can be edited in the tab like in an Excel sheet. If you make any changes, remember to save them on top of the former topo layout file for the specific montage that you're using, otherwise it will not be saved. Over to the Channel Masking tab, we will see a matrix view of the channels in the chosen montage. This is done automatically from the montage files. So, for example, here we have a channel between source 3 and detector 5. Any active channels of the montage will be painted blue, which means that the software will show real-time data for this combination of source and detector. If for some reason you would not like to see some channels, you can click on it and it will turn from blue to white, meaning it's now inactive. If any unintentional changes are made, you can always click Apply Topo Layout and restore it to the original version. In the Display Setup tab, we can set up the conditions for the experiment and the block average settings. For example, if you're running a finger tapping experiment, you will need two markers for the left and right hand conditions. Here, you define the numbers that the trigger markers will be saved as. Remember to assign each condition to a trigger number prior to the experiment, so that you know that marker 1 is, for example, the left hand condition and marker 2 is the right hand condition. Display conditions for the block average can be also set here. Next, we have the HB parameter tab, where you can set the parameters for calculating the modified Beer-Lambert law. You can change the oxy and deoxyhemoglobin absorption values, the source detector separation for all channels or for specific channels, the differential path length factor according to subject age, and how many points are used for the baseline calculation. Keep in mind that changing any of these parameters will not change the saved data, which is always raw. So these are for display purposes only. In the Data Streaming tab, we can set up NIRStar to receive triggers via lab streaming layer from stimulus presentation software, for example. To do this, you have to turn on the Receive Triggers button, set up a stream name, and choose a fallback trigger ID. This ID is used as a default if any of the received triggers are not recognized by NIRStar. This tab also lets you test the lab streaming layer connection before running an experiment, which can be extremely useful to avoid mistakes. The last tab is the Hardware Specification tab, where we can set up the study type if we are, for example, doing a phantom experiment. The rest of the information should only be changed if there are any changes to the hardware. For example, if short channels are to be integrated in the measurement, you should check the box and the number of bundles, and it should automatically assign the specific detectors that should be connected to the short channel bundles. Once we are done with our configuration, we can hit Save and close this menu. To the right of the hardware configuration, if your system is a NIRScout Extended Plus, you will have access to the Digital I/O menu. This menu allows you to configure a trigger output from your device to synchronize with other equipment, for example. These triggers can be configured over 8 channels in 3 ways: start markers, post sequences, or stop markers. Once you're done with setting this up, you can go ahead and click OK. Next, we have the Diagnostics menu. Here, we can measure the IRMS noise amplitude for each detector for different gains and wavelengths, and we can save these results for troubleshooting if needed. The File Options menu is very important, as it defines where your grade datasets will be saved, the prefix of this data, and allow you to check different options regarding saving, including the Save Data to Homer 2 option. This option should always be checked, since the .NIRS format is compatible and can be used directly with most of the available toolboxes like Satori, the NIRS toolbox, and Homer 3. Speaking of data, the default directory for NIRStar is C then NIRx. You can see the saved data files on the Data folder. They are identified by the date of the recording and run number. Once you enter any of these folders, you will see the structure of the saved data files. These files include the detector readings WL1 and WL2, a header file with information surrounding the recording such as montage details and event timings, and other files which have redundant isolated information to the .hdr file, in case you want to check them individually. If you have selected the Export Data to Homer 2 format, a .NIRS file should also be present here. Back to the root folder, the Montages folder stores all of our possible configurations. And if you have created a new montage or exported a montage using NIRSite, this is where it should be pasted to. You can also access software-related files if you go back to the root folder and then access the NIRStar folder. Now that we are familiar with the setup and know where to find our data, we can start up the recording process. To start, we can go to the landing page and pay attention to the main function section. There, we first perform a system calibration. This will make sure that each detector has the correct gain for this recording. Once the calibration is finished, the signal quality section of the page will light up with our topo layout in a color map. This color map represents the data quality class for each of our channels. Generally, we aim for all excellent channels, but all excellent or acceptable channels is also great. This step should always be performed before a measurement, as it will guarantee the best data quality for your recording, and also will allow you to check and fix any particularly noisy channels or regions before acquiring data. If you click on Details, you will see the specific values that go into the quality scale factor individually: gain, level, noise, and dark noise. Here, you can hit Save to save these results for troubleshooting purposes. After calibrating, we can go ahead and start a preview. Hitting preview will start a recording without saving any data. During a preview or a recording, we will be taken to the Data Visualization tab, where we can see the oxy and deoxy concentration changes in real time for all channels. Over the top of the page, we can set the zoom to see more or less channels at the same time, show the channel labels, and change the scale of the data for better visualization, especially in the case we have a very noisy channel, which should be rare when using our systems. On the bottom of the page, we can renormalize the modified Beer-Lumber law calculation, clear the chart, or set different values for a low-pass filter. Once again, remember that none of this will change the save data, as we always save the raw detector readings. Manual triggers can also be added by simply pressing the F keys or by clicking the respective trigger value. After recording a few triggers, we can see the block averages for different conditions in the Block Averages tab. Here, we can assign different conditions to the markers that were declared previously and also change the time window and scale factor of what we're looking at. If we click Open, we can see the block averages for all channels and all conditions at the same time. Going back now to the data visualization page, if we hit Stop then Record, we will actually start saving our data. Once you're done with data collection, if you click Stop, it will, well, stop the recording and save your data. Once it's saved and converted to HOMER2 format, you can access it on the data folder that I showed you earlier. Clicking the Help button will take you to the NIRStar user manual, where you can find lots of useful information about the software and how to use it. Well, that's it for this video. I hope you enjoyed it and found it helpful. If you still have questions or need help with anything NIRx related, feel free to contact us at support.nirx.net, as our support is free and awesome. Thank you for watching and have a wonderful day.